I'm on my way.
Let me read the question now. Diagram 4 shows locations of 4 stations in the school field on a Cartesian plane such that BCDE is a parallelogram. Okay, as you can see here, this is the diagram BCDE. It's in the parallelogram shape, and you have the coordinate B and E with the coordinate 5, 11 and 1, 1 respectively. So let me read the question part A. State the value of magnitude of vector ED plus with vector DB plus with vector BE. Okay, the magnitude. So that's the one we're going to find for the question part A. Let me read the question part B. A path from station E to station D is parallel to the x-axis and the displacement is 11 meter. Using vector's triangle law, find the resultant vector from station E to station C. Okay, continue to read the question part C. A boy runs from station E to a cone at K at the coordinate K bracket 5P with a constant velocity of 3I plus 4J meter per second. So this is the vector which the velocity is in the vector form. Okay, he takes t seconds to reach the cone. Okay, to reach the cone. So based on the given information, write a vector equation in terms of t and p, hence find the value of t and p. Okay, so this is the overall question. Okay, so I'm going to give you a step-by-step explanation, guys. Okay, so please watch this video till the end. Okay, so let us begin our discussion for the question part A. Okay, for the question part A, so I'm going to explain you in terms of two methods. Okay, even though it's a 1 mark question, it's actually very straightforward. The answer is actually 0. Wait, what? So you just straight away tell me 0. So I'm sure you are expecting the explanation, a proper explanation. How come it gets 0? So for that, I'm going to use two methods over here. So how you can get 0? Okay, number one, using the mathematical equation form. Okay, where I'll be doing the vector equation, and then towards the end you will be getting 0. Okay, and the second method is by sketching the vector itself. You can prove that way also by getting the answer 0. Okay, so now I'm going to explain to you why the summation of vector, the summation of the vector ED plus with vector DB and with vector BE, and then you get the magnitude of the summation is equals to 0. Okay, so from here, so what I'm going to do now is I'm going to use the triangle law, guys, in this case. Okay, which in the form of a mathematical equation. So let me write the working here. For instance, using triangle law, okay, which in this case using mathematical equation, okay. So from here, let us calculate one of the component of the vector first. Okay, basically if we're using a mathematical equation, for example, let's say we take EB for example. Okay, to get the EB, vector EB, so how we form the vector EB? Okay, vector EB will be equals to vector ED plus with vector DB. Okay, so this is your vector EB, guys. Okay, the vector EB you can form through the addition of the vector, which is vector ED plus with vector DB. So these two summation of vector you will get towards the vector EB itself. Okay, so let me box this. Okay, so from here back to our main working. Okay, so what I'm going to do now is I'm going to write down the modulus equation over here. So equals to modulus. So vector ED plus with vector DB plus with vector BE. Okay, so take a note at this statement over here, guys. You have vector ED plus with vector DB plus with vector BE. Okay, so this vector ED and vector DB we can substitute with vector EB itself. Okay, so from here, since vector EB is equals to vector ED plus with DB, and you have exactly the same expression, so we can substitute it with EB. So vector EB plus with BE. Okay, so vector EB is from down to up, okay, in this direction, whereas vector BE is from up to down or top to bottom. Same vector but in opposite direction. Okay, the difference between vector EB and BE is they are in just opposite direction. So when you plus together a two opposite direction, your answer will be 0. For example, vector EB, for example guys, okay, let's say vector EB you get is A. So if vector EB is A, vector BE will be negative A. So A minus A, 0. So that is the explanation behind this, guys. Okay, using the triangle law. Okay, in this case I use the mathematical equation. So where you can ask me, so where is the triangle? This is the triangle. Where are, guys? The EDB. Okay, so this is the explanation I'm trying to tell you. So to get the vector EB, so ED plus with DB, so that's how you get the EB, but then you plus with BE, the opposite direction itself, so the resultant of those two vectors you get is 0. Okay, so this is just for the explanation for the EB and vector BE, guys. Okay, in case if you didn't get it. So this is the mathematical equation. Okay, so let me show you the vector concept itself. So now what I'm going to do is I'm going to sketch a triangle. Okay, a simple triangle. Okay, which fits something like the question. So EDB, EDB. Okay, you have here E with the coordinate 1, 1, B with the coordinate 5, 11. Okay, so technically we want vector ED plus with vector DB plus with vector BE. It's going back to the original place. So can you see here? It's going back to the original place. So technically the summation of the vector, the magnitude of the vector will be equals to 0. Okay, because it's coming back to the starting point itself. Usually when you are adding a vector, the resultant of this vector ED plus DB will be in this way, E to B, but then the question is showing in this way itself, is showing downwards. So the summation of the vector will be 0. Okay, the magnitude of the vector, guys, in this case I'm telling you is equals to 0. Okay, so from here I can say summation of the magnitude of vector is equals to 0. Okay, so I've shown you two methods. Okay, you can ask me just for the 1 mark, so why you need to show so many explanation? Okay, there is need, guys, for you to understand. Okay, some of the students may not be able to understand. Okay, why they just have a how can you can get 0? Okay, show me some explanation. So these are the explanations, so that I can prove you to that, and this is how you get the answer 0. Okay, you can use the equation or you can use the diagram. Somehow you will get the same answer. Okay. And that is all for the discussion for the question part A. So let me proceed our discussion for the question part B. Okay, let me read the question part B. They said a path from station E to D is parallel to the x-axis. Okay, and then they already tell us that the displacement is 11 meter. Okay, that is our first clue, guys. Okay, please take note, displacement is 11 meter. So my advice to the students, whenever you get the information, quickly write down, okay, in your working. So from here, displacement of D from point E technically is equals to 11 meter. Okay, and we know that the coordinate E is actually 1 1. So technically your coordinate D is equals to, so how to get the coordinate D? Very simple. Okay, you just add the x-axis. So for the x coordinate, guys. Okay, so the 1 you just plus with 11, you get 12. So from here you get your coordinate D is 12, 1. Okay, your y-axis is still the same. Okay, only your x is displaced by 11 meter. Okay, so this is your coordinate D. Okay, this is not the answer. Okay, I'm just writing the first step to find the coordinate D. Okay, and then they ask us to find the resultant vector from station E to station C. So we need to find the resultant vector of EC. Okay, so to find this, you can use two methods. Okay, you can either use the summation of ED plus with DC, or you can use the summation of EB plus with BC. Either way, you will still get back the same answer, which is the vector EC. Okay, I'm going to show you the two methods. Okay, but before that, our next step will be, okay, since we are finding the coordinate D, our next step is important for us to find the coordinate C as well. Okay, and they already gave us the hint that is a parallelogram. Okay, in the question that BCDE is a parallelogram. Okay, that means that if coordinate ED is displaced by 11 meter, BC should also be displaced by 11 meter. Okay, so that is the clue, the hidden clue, guys. Okay, they already gave us that BCDE is a parallelogram, and the second clue is the displacement is 11 meter from station E to station D, E to D. So that means that your point B to C must also be displaced by 11 meter. Okay, so from here, let me write the explanation here. So since BCDE is a parallelogram, so from here your coordinate C is equals to, same concept, guys, you just add the x coordinate value. So 5 plus with 11, you get is 16. So from here you get your coordinate C is 16, 11. Okay, so coordinate C in this case is 16, 11. Close bracket. So let me close this. Okay, so now we know the coordinate D and coordinate C. Okay, so sorry guys, I'm literally flipping up and down. Okay, we know coordinate D and coordinate C. Now we can able to find the resultant vector. Since we have all the 4 vertex coordinates, okay, we can use either method to calculate the resultant vector of EC. So now we're going to use the method 1 by summing the vector ED plus with vector DC. Okay. So let us proceed with the method 1. Okay, so from here, resultant vector EC, okay, you can find them using the summation of vector ED plus with vector DC. Okay, so from here, vector EC is equals to, okay, so how to get the vector ED? Okay, very simple, guys. Okay, they already gave us the hint that the displacement is 11 meter. So that means there will be no changes in y coordinate. So the difference between y coordinate will be 0. But the difference between the x coordinate will be 11. So we write our vector in ij format. So since I represent the x coordinate, so we will just write our vector ED as 11i. So 11i plus with vector DC. Okay, of course for the vector DC you need to do some calculation. Okay, let me write the coordinate over here. So coordinate D in this case is 12, 1, 12, 1. Okay, over here is 16, 11. Okay, so in order to find the vector DC, so you need to minus the difference between them. So 16 minus 12 you get is 4, 11 minus 1 you get is 10. So since we write our vector in terms of I and j format, so it will be 4i plus with 10j. So this will be your vector DC. Okay, so that's how you calculate your vector, guys. Okay, between 2 points. Okay, so from here, vector DC is equals to 4i plus with 10j. So from here, vector EC, okay, it will be equals to, okay, we begin our calculation with the I, summation of I. So 11i plus 4i will be 15i. Okay, plus with 10j. Okay, so this is our method 1. So let me underline this. Okay, so from here we have already discussed the method 1. Okay, if you are sitting in the examination, just do one method is enough, guys, because you are chasing the time. Okay, but for your learning, for your understanding, I'm just showing that there is also another way that you can use to solve the problem. Okay, I'm repeating this again. Okay, some of you might be thinking why my videos are so long. Okay, it's because that I want to explain in a proper way that there is another way that you can use to solve a particular problem. Okay, so this is the method 1. Okay, I'm going to show you the second method, method 2. Okay, so our second method in this case will be, since we are finding the resultant vector of EC, so we will be using the vector EB plus with vector BC. Okay, so from here, vector EB, similar concept for the DC, we need to find the difference between these two. Okay, so from here, start with the X, so 5 minus 1 will be 4, 11 minus 1 is 10, so vector EB will be 4i plus with 10j. Okay, and then vector BC, similar concept, it is displaced by 11 meter in the x coordinate. So y coordinate there will be no changes, only your x is actually displaced by 11. So technically, since x is represented as I, so you just write as 11i for BC. So method 2, vector EC is equals to vector EB plus with vector BC. Okay, so from here, vector EC is equals to, okay, vector EB, like we have calculated, is 4i plus with 10j. Okay, plus with vector BC, okay, like we have calculated, is 11i. Okay, so from here vector EC will be equals to, let us begin our calculation with the I. So 4i plus 11i is 15i. So and then you plus with the j. Okay, so from here 15i plus with 10j. Are the two answers the same? Either method you use, you will get the same answer. Okay, so I hope that you understand the explanation crystal clear, guys. Okay, so let me just underline the solution for method 2. Okay, in the examination you can just use either one of the method, should be enough. Okay, so from here let us proceed to our last sub question, which is the part C. Okay, so for the part C, the question mentioned that the boy runs from station E to a cone at a particular coordinate with a constant velocity. Okay, and then he takes the t second to reach the cone, and then we need to write a vector equation in terms of t and p, and then we need to find the value of t and p. Okay, so from here, one thing you need to take the note, the coordinates in displacement, not vector, guys. So you cannot just straight away use the method that we have used for the question part B and then you can minus. No. Okay, so here you need to be extra careful. Coordinates in displacement, and then they gave us the velocity in vector form. Okay, in this case is 3i plus with 4j meter per second. Okay, and they also give us it requires t second to reach the cone. Okay, so from here, before solving this question, it is important for us to standardize the vectors. Okay, because as you can see, now you have displacement and then the question gave you velocity and then they gave you the time some. Okay, you have three variables. So the step one, what you need to do is you need to standardize them into one single type of vector, I would say. So let's say in this case I would recommend you to standardize everything into the displacement form, which will be easier for us to solve. As you can see here in this diagram, most of our vectors are in displacement form. So I strongly recommend you to convert whatever information that you have in terms in displacement form. So how are you going to standardize the vector? Remember guys, velocity is equal to displacement over time, physics. Okay, so you need to apply the physics knowledge in your additional mathematics. So from here, let me write the working here. So step 1, standardize the vector. Okay, and then it is important to us to use the formula velocity is equals to displacement over time. Okay, so let me draw the fraction line. Okay, and since we are calculating the displacement, so it will be equals to velocity times with time times with time. Okay, so we have touched a bit of physics over here. So for this question we are going to use the matrix form in order to solve the vector. Okay, there are two methods. One, you can use the IJ form, another one you can use the matrix form. So we are using the matrix form in this case. So the question already gave us that the boy runs from station E to a particular coordinate from point K. Okay, and then with the constant velocity over here. So from here, what you need to do is you need to sum the point E, okay, which in this case the 1 1, okay, and then the velocity times with the particular time, and then you should able to get the point K, because point E plus the displacement, you should able to get that point K. So how are you going to get the displacement from here? I'm going to show it to you now. Okay, so from here, point E, so you write the ij form 1 1 plus with the velocity times with the time, so 3i plus 4j, okay, times with the time t over here. So these two, you plus them together, this is actually a displacement itself, okay, velocity, time, so you times them together, you get the displacement, and this is also a displacement. So you plus them together, you should get equals to the point K, which in this case the point K is 5p. This is your point E, this is your displacement, and this is your point K. So you add them together, you should get equally the same. Okay, let us solve the vector together. So vector 1 1 plus with the t you expand in, okay, using the matrix concept, the t you times 3 and 4 over here, you get 3t plus with 4t. Okay, equals to 5 comma p. Okay, let us continue. So let us do the comparison of the matrix. Okay, let us start with the x coordinate, the I component, I will say x component, I will say in this case. So from here 1 plus 3t is equals to 5. So 3t is equals to 5 minus 1, the 1 from the left hand side you move it over to the right hand side, so from here 3t is equals to 4. So from here get your time t is equals to 4 over 3 second. Okay, so you already get your value t over here. So let us proceed to our second comparison. 1 plus 4t is equals to p. Okay, you have two variables here, but then we already know the value of t. So in order for us to find the value of p here, this 4 over 3 we can substitute at this equation over here. So from here 1 plus with 4, okay, times with 4 over 3 is equals to p. Okay, so times the 4 inside the fraction, so from here 1 plus 16 over 3 is equals to p. Okay, so this one, let us break the fraction, so 3 over 3 plus with 16 over 3 is equals to p. Okay, 3 plus 16 you get is 19 over 3 is equals to p, and therefore you get your p is equals to 19 over 3. So this is your final answer. Therefore p is equals to 19 over 3. Okay, so let me underline the second solution. Alright, okay, let me scroll this up. Okay, so that is all for the discussion for the SPM 2021 paper 1 additional mathematics question number 7. So I hope you have understand the question and plus with my full explanation for the question number 7. Okay, so if you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming Add Maths tutorial videos in the future. And of course, make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.